We'll begin by turning familiar financial instruments, bonds, funds, equities, and real-world assets, into digital asset models. The key is to capture rights, restrictions, and obligations first, because those decisions drive token standards, smart contracts, and the full asset lifecycle. You've now moved from strategy to platform choice. You understand the market, architecture, stakeholders, network models, tooling, and selection trade-offs. Now we shift focus to the asset itself. Before choosing token standards or writing smart contracts, we need a precise model of what is being issued. A token standard should never be the first architectural decision. Start by modeling the asset, what it represents, what rights it gives, who may hold it, how transfers work, and what happens throughout its lifecycle. Those choices define the business and compliance rules. Only then can you select a standard, such as ERC20, ERC1400, or ERC3643. If the model is vague, the contracts may encode the wrong product, creating redesign costs and compliance gaps. Before designing controls, classify what the asset actually is. A fungible token with cash flow rights and broad transferability creates very different obligations than a restricted token representing debt or fund interests. Classification drives issuance rules, custody model, transfer checks, investor reporting, and lifecycle events like redemption or lockups. The goal is not labeling for its own sake. It is to connect asset features to the legal, operational, and technical controls they require. The first design choice is whether each token is interchangeable, unique, or somewhere in between. Fungible tokens fit shares, bond units, fund units, and cash-like claims, because every unit behaves the same. Non-fungible tokens fit individually identified assets or certificates. Semi-fungible designs handle groups that share traits but differ by tranche, series, lockup, or vintage. This choice affects balances, metadata, valuation, reporting, transfers, and market compatibility. Think of the token as the interface, not automatically the source of truth. Its value depends on the legal claim behind it. First ask whether ownership lives on-chain, in an external registry, or in contract documents. Then map exactly what the holder receives: dividends, coupons, redemption proceeds, voting rights, consent rights, or information access. That mapping makes transfers, restrictions, and investor protections enforceable rather than merely recorded. For regulated digital assets, transferability is more than a token function. A transfer request must show that the sender and recipient are known, eligible, and permitted under the relevant rules. That can include whitelist checks, jurisdiction screens, lockup periods, sanctions review, and limits on investor type or concentration. Validation may happen on-chain, off-chain, or through a hybrid model. If a transfer is blocked, the system should record a clear, auditable reason. Designing a tokenized bond starts with translating the term sheet into system logic. Issuance details define token supply, denomination, currency, maturity, and identifiers. Coupon rules drive payment calculations and schedules. Lifecycle events require automation for interest, principal, early redemption, default, and corporate actions. Compliance then adds guardrails: who can hold the bond, when transfers are allowed, how settlement occurs, and what reporting is required. The goal is simple. Every legal promise must become an enforceable digital process. A fund token represents a more dynamic operational relationship. First, define the fund type, because a private fund, money market fund, and feeder fund all have different dealing rules. Then model subscriptions, lockups, gates, transfers, distributions, and redemptions. NAV and unit pricing must feed the token logic, while the administrator's books remain the official record. The design goal is continuous reconciliation between investor balances, valuation, and fund operations. Equity tokens are not just wallet balances. They represent legal and economic relationships that must stay synchronized with the company's cap table and official records. The model needs to capture share class, transfer restrictions, voting rights, dividend entitlements, and investor eligibility. It also has to handle real corporate events: splits, buybacks, mergers, conversions, and class changes. A strong equity token system connects smart contracts to governance, compliance, and record-keeping processes. Tokenizing a real-world asset requires more than minting a token. The asset first needs a legal wrapper that gives investors an enforceable claim, such as an SPV, trust, fund unit, or note. Its value must be supported by appraisals, market data, audits, or oracles. Custody proves the asset exists and is controlled. Compliance rules, insurance, liquidation rights, substitution procedures, and dispute handling then help keep the token tied to reality. The key architecture question is, which system actually proves ownership? In some designs, the blockchain ledger is authoritative, so token balances are the legal record. In many regulated markets, the chain is only a synchronized view of records maintained by transfer agents, registrars, custodians, or fund administrators. That choice affects wallet design, account structures, and dispute handling. Whenever ownership exists in more than one place, reconciliation controls become part of the core architecture. Asset models need more than balances. They need a clear data boundary. Stable facts such as the asset name, symbol, issuance date, and product type can often be recorded directly on-chain. Changing values such as NAV, coupon status, eligibility, or lifecycle events may be updated through controlled sources. Sensitive investor files and legal documents usually stay off-chain. The chain can then store hashes, document IDs, oracle links, and event logs, keeping records verifiable without exposing everything. The target digital asset model is the bridge between business design and technical architecture. Start by classifying the asset and the rights it represents. Then define who is eligible, what transfers are restricted, and which lifecycle events must be handled, from issuance through redemption or maturity. Next, identify the authoritative records, reconciliation process, reporting obligations, and off-chain dependencies. Only after that should you choose token standards and decompose smart contracts, because the model should drive the implementation. Tokenization is an architecture problem, not just an issuance step. Classify the asset, then model its rights, restrictions, lifecycle events, transfer controls, and registries. Finally, decide the source of truth across the blockchain and existing institutions. Next, we'll compare token standards and connect them to smart contract design.